Swayam Prabha. Digital India. Educated India.
Good morning everybody, and let us continue our lecture related to the component of the machine tool. In the last class we have seen some of the different configuration of the rib, so that you can reduce the weight of the machine tool structure, and we have also seen that we can use some of the lightweight materials such as aluminum alloy for making some of the components, so that we can reduce the weight without sacrificing the strength of the material. So, these type of options are very important to understand, that how we can make the system economically without sacrificing or without actually deviating from the required goal. So, let us continue this topic further. So, this thing what we have discussed in the last class, lightweight material, and criteria for material selection, that once we know that what is the final design, and then we have to finalize that some of the properties by which we can get the different materials out of it. Suppose first thing is the precision application. Suppose your requirement is of precision application, then what we have to see, that we have to see the thermal and long term stability of the structure, that is very essential. So, you have to find some materials which are not very have a less thermal coefficient expansion, and also you have to find something which is rigid, so that long term stability is important, because it will not deform by itself or because of the machining forces, and later case after few years you may get trouble out of trouble from the machines. Lightweight construction is desired for moving component, that we have seen, that if it is not lightweight, then the axis movement from here to here, it will take some time, because you have to gain that you have to overcome the inertia forces, so that you can get the required particular motion for moving from one location to the another location. So, the lightweight construction is important, but again you have to see that it should be stable and it should be very strong, because some of times lightweight structure are not that much stable, and you might end up with the wrong design calculation. Then the high damping and stability should be provided to the by the base machine base. So, now what is important, because we know that our base is very important. Now, consider this is the base. Now, what is problem if your base has no high damping or stability? Now, we know that we are putting the guideway here on the top. On the guideway, what we have, XY table. On the top we have a workpiece fixture, and on the top we have workpiece, correct. This is the static loading, whatever we are talking about, and then on the other side, now consider this is the structure, then on the top side this is the spindle housing, then this is the collet, and then this is the tool, correct. So, now when you do actual machine, that time vibration will be propagated in the different directions, right. So, vibration may go in this direction, vibration will go in this direction also. So, that is related to the damping capacity. So, if because now workpiece fixture, these are the external part, because this will be frequently changed depending on the selection of the workpiece. XY table guideway, these are the fixed, these are the machine components. So, when you decide some material for the XY table and the guideway material, then you have to think about the damping property, because whatever forces occurs here at this location at that time, it will propagate from workpiece to the workpiece fixture, and then it will go to the XY table. So, if your XY table has a high damping, capacity, then it will not propagate the vibration further in the this direction. So, it will not go in downward, it will absorb everything within that material only. So, you have to think about that also. Another thing about the stability, because now we know that this whole thing are weight. So, it has some weight, of this component, right. So, when everything is loaded on the base, at that time base will deform itself also, even in static mode. Forget about the machining. When you do machining, at that time it will come across the static load as well as the dynamic load also. So, it should have a high damping and stability in the base material. So, your whole structure should not deform at that time, because base is the thing which is taking most of the load out of this particular machine tool, and if that is deformed or it has some type of dimensional problem, at that time that dimensional problem or the defects, that will be actually replicated or reflected into the component which you are machining. So, you may not get the required dimension and you will end up with that geometric error that we have seen in the different axes in 1 or 2 lectures before. Correct. So, light stiff design, how you can define the correctly placed material in the right shape while using as little material as possible. So, now what is the criteria for getting this particular design? That first thing is that material should be less material, then right shape. First you find out the how much material you want to take, it should be less material, then you have to shape it, then you have to find out what is the right shape for making, that we have seen in the different type of rib construction, correct. So, we have to find out how much less material you can use and what is the shape which is giving more stability, and that is now where we have to place this thing. So, then it is a placement, correct. So, now we have to see the what is the loading direction. So, that is placement based on loading or force direction, right. So, you have to see that which direction you are loading. So, if your joint or whatever particular material is in the same direction, then you have to see that what is the strength of that material. So, at that time you have to get the light stiff design based on this particular criteria. So, now what is the good design? Now, good design leads to a uniform distributed loading. Now, we know that we have a loading at a one concentrated point. Now, when you do machining operation and this is your workpiece, and when you are drilling at that time, whatever thrust force is occurring here, and because of this thrust force it will go to the collet and then collet to the spindle housing, correct. So, now when it is going from one component to another component, your distribution of loading should be uniform. That means, it should not that one component is stressed more and another component is less stressed, because if you are end up with the non-uniform loading, then one material is deformed very more and another material will not deform at all. So, because of that uneven deformation, you may get some permanent deformation in the workpiece geometries, right. So, ideally the stress level under load should be same for all the material used. Now, we have seen that we can use different materials, and we have also seen that one particular material is not useful for making the whole system or the whole machine. So, we are using different material at different location for making different components, and because of that all materials have different properties, and that different properties are creating a different stress level, and we have to make sure that the whatever stresses are generated, it should be same for all material. That we have seen in the last class, that if one is the making of this is the cast iron, then if you are using a aluminum, then actually you can increase the size of this component. So, this is aluminum alloy. you can increase the volume, then actually you can maintain the stress level under the same loading. So, whatever loading is here, if you are making this cast iron size and the aluminum size same, then aluminum will be more stressed compared to cast iron. But if you keep the area little bit high in such a way that your total load or the total weight is not increased, but these are equal, then actually you can maintain the stress level in the different components, right. So, now construction material for the machine tools. Now, this is one of the base of the machines. Now, what are the materials are mostly used? Cast iron and granite are most widely used material for machine base and slide base because of their some of the properties. It is one is the good wear resistance, because if you see all the conventional lathe machine and the milling machine, your base you will find the cast iron. Granite is next to cast iron, which is also widely used. Low thermal expansion, because even if there is a temperature difference in the climate, because mostly when you install a conventional lathe machine or milling machine, generally you do not provide the envelope on the top. So, because of that, what happens that whenever you are operating in a summer or you are operating in a winter, temperature difference is more than 30-40 degrees in some of the locations. So, because of that, you may not get large variation in the thermal deformation because of the climate temperature difference. Low stress cause deformation, because when you are using this material, these materials are subjected to less deformation when under stress, and the high vibration damping capacity. So, whenever there is a vibration, this vibration will be propagated or it will be absorbed within this end only. It will not actually transfer to the other component or other joint. So, these are the some of the advantages of this particular materials, so that you can use it comfortably for the different applications. But some of the issues are there when you are going to use this material for the micro machining center, because right now these are widely used for conventional machining, where we are not looking at the detail at micron level or tens of micron level. But when our component and the machining parameters setting it considered as a micron accuracy or sub-micron accuracy, this material selection will play important role in the construction. So, let us see those things. So, this is the granite. So, granite base is very useful compared to the cast iron, because it is a crystalline hard stone consists of quartz, mica and the feldspar. So, combination of this thing is considered called as a granite structure. What are the important properties? That it has high damping, that means whatever vibrations are there, it will absorb itself, it will not propagate or transfer to the other material. Low thermal conductivity, it is 3.2 watt per meter Kelvin. Low thermal expansion, so it will expand 5 to 6 micron per meter in a per degree of Kelvin change. So, if you consider any component, suppose this is one component and this is 1 meter of length, 1 meter length, and there is a temperature is changed. So, delta K is 1 K. Okay. So, whatever is this 1 K, whatever change you will get, in terms of volumetric change, you will get 5 to 6 micron, correct. So, this is reasonably good for certain components, but when you are talking about a micro machining, where sometimes your desktop cut itself is in 5 to 6 micron, at that time it may create some problem at the later stage. High hardness is one of the parameters by which you can select this thing for a micro machining or some reasonably good macro machine parts. Abrasion resistance is there and absence of residual stresses, because if you make a component from the cast iron or some other steel material, at that time you have to actually machine those components, correct. And if when you do machining, at that time there is a cutting forces include. If you go by a casting process or powder metallurgy, there are residual stresses you have to relieve before you use for end operation, but here you will not get a residual stresses. That is one of the advantages, so that you do not need to post process the whatever structure you have fabricated out of the granite. But same thing you have to do for the cast iron, because after once the processing of this particular structure is over, you have to pass through the stress relieving operation, so that it should not create any problem at the later stage. But if you see the granite is also used for combining with the steel material or some other materials. So, now if that is the case, then what you have to do, that you have to check the thermal properties to avoid bending and stresses at the interface. Now, consider, now steel has a coefficient of thermal expansion 11 to 13, but this particular thing is a 5 to 6 only. Now, see how this thing will make difference. Now, consider, let us take one example, that you have a 2 strip, this is the 2 strip and this one as a alpha 1 and this one as a alpha 2. Okay. So, alpha is the coefficient of thermal expansion. Okay. And consider alpha 1 is higher than alpha 2. Now, you heat this component. Okay. So, this is the interface, now you are heating. Okay. Now, we know that alpha 1 has high coefficient of thermal expansion. So, this will expand or it will respond very quickly to the temperature change. But now, what is our objective? We want to keep this thing straight. But now, if this is the temperature, then what is happened, that finally you are end up with the bending of this thing, correct, because this will start expanding, but this will not respond quickly because it has a low thermal expansion. So, it will remain within that particular range only where it is where it is expanding, but this will respond to more to the temperature. So, this will bend because now it is more expanded. So, now what is happening here in this particular case? Now, if you have two material, one is the stainless steel and another one is the granite, and you have interface. Okay. So, this is the granite and this is a steel. Now, again you are this both the components are subjected to the heat. Now, what is going to happen? Your steel will expand more compared to the granite, right. So, when you are utilizing or using the combination of this thing, that means you are keeping both the things together, granite and the steel, at that time you have to make sure that temperature is not very fluctuating within that particular system. Even there is a 1 degree or less than 1 degree change, that is enough to create some problem at the interface, or it will create a bending, that is because of this particular thing. Now, if you see, if it is bending more, then what will happen? Interface will be different. Now, this interface may create some problem because now it will slip along this interface, because one material is deforming or sliding over the other face because of the temperature difference. So, bending is one of the case and the stresses will be there in the interface, and finally, joint will be loose, and that is what you want to avoid for the long period of time. So, that is what is in terms of granite. So, what is the drawback of the granite? It absorbs moisture, because when you are using this in some type of humid environment where the temperature, you are maintaining temperature, but humidity is very high, then it is creating problem. So, where it is creating, because when it is humid at that time, it will become very sticky. So, when you are using granite as a micro machining machine tool construction material, at that time the moisture will create important, but there is one of the remedies, that either you use into dry environment, you maintain the humidity below a permissible limit, so that still you can use the granite, or other thing what you can do, you provide a sealing of the granite with the epoxy resin. So, once you make this component, then what you do, that you provide the epoxy resin. So, whatever moisture is there, moisture will not come into contact with the granite, and you can actually keep this particular structure safe against the high moisture. Then another material is polymer concrete. So, this is the complete structure, one of the structures by which you can make the monolithic structure. So, now what things are there, that suppose here what you can see, that here one guideway is given here, that is the inbuilt here. So, you may get one x axis in this direction. Now, these are the two guideways are given here in this. So, you will mount one other guideway for moving in the y axis here, and on the top of that, or here also you are providing two location where bolts are there. So, maybe the z axis is coming from this particular location. So, you can see that many things you have to provide it you have to provide in this particular structure, so that at the end you do not need to drill also. So, many times when you are casting this such a big things, at that time you provide some of the things very comfortably. So, you do not need to do any type of extra machining for making those particular things. So, let us see what is the polymer concrete. Right. So, polymer concrete consists of, one is the filler material. So, what are the filler material? The sand, marble, quartz, pearlite, glass, fiber, dolomite, steel or the carbon fiber. So, these are the filler material. So, you have to mix this filler material for the resin. So, if you mix two things, what are the resins? Unsaturated polyester, polymethyl methacrylate or epoxy. So, you mix two these things in the presence of catalyst or the accelerant. So, what is the role of this catalyst accelerant? So, they will keep the property of these particular materials intact. So, this thing will not change when you are actually processing those things, and it will also avoid the effect of the external parameters, temperature or maybe the humidity or other things. It will not create any problem. So, you have to add some type of catalyst or accelerant which will actually increase the probability of proper mixing of those two things, and it will also reduce the total time, and all things you have to do at the room temperature. So, once you make two things, you mix it along with the catalyst, then there is a polymerization happens between these all the three things, and then it becomes very, very tough. So, this is the way you can make the polymer concrete. So, polymer concrete is the most suitable machine frame material for the micro milling process. So, why it is so? Let us see this. So, it is up to 10 times higher absorption of the vibration than the cast iron. So, this is one of the examples of the Kern machine. So, that machine we will see the demonstration sometime later. So, this is the vibration amplitude in the cast iron. So, this is the cast iron and this is the vibration amplitude, and time is in terms of the 0.1 second. So, this is 0.1, 0.2, 0.3 and this is the vibration level in +2 -3 micron. Now, if you see that when there is a vibration of this particular magnitude, it is a 6 magnitude, 6 micron magnitude plus or minus 3, then what is happening here, that it is actually not diminishing to the 0 even after 1 full second. Now, if you consider this is 9 and this is the 1 second, after 1 second still it is there, and if you actually extrapolate this particular graph, it may continue for another 1 second. So, after 2 second or 3 second you may get a vibration diminish. But if you see the polymer concrete, now initially with the same loading, you are, first thing is you are not getting enough vibration here, right. So, it will absorb, and within plus or minus 1 micron, what is going to happen there, within 0.4 or 0.5 micron your vibration is almost 0 in this case. And sometimes whatever this particular vibration also may not create any problem, because it is within that particular acceptable limit of the machine tool, and that is the advantage of using polymer concrete for a structural material in place of cast iron or the granite material, because both have some disadvantages, and polymer concrete is actually overcome all the disadvantages of the cast iron and the granite material. Substantially better thermal stability than the cast iron, superior dynamic and static rigidity, and the lightweight, because now you are using a polymer, and concrete is a polymer is actually the one of the components which is very, very light in weight, and here cast iron you are granite you are using mostly it is a stone based thing, and you are not mixing anything there. So, its weight is also very high. Cast iron is actually the metallic component, so obviously its weight is very, very high. But here concrete is one of the components which weight may be high, but you are using polymer also. So, depending on the proportion of the polymer and the cast concrete at that time, that depends on the what is the total weight of the polymer concrete, correct. So, that is the lightweight, superior dynamic and static rigidity, that is also important. So, now this is the one of the graphs it is showing. So, this is the cast iron, and now whatever we are putting that per Newton, there is a problem, there is a deviation with the 0.5 0.3 micron. So, if you provide 1 Newton load, then you will get a deformation of 0.3 micron. So, that is bending moment or maybe the thrust force or whatever way you are putting it. So, if you are providing this, so this is the scale of that, this much is the scale of this part. So, when you are putting a load in this direction or impact in this direction, what is happening, that this particular thing is not very rigid in structure. So, now if you see this much is the vibration or this much is the deformation in that deformation is in a double the amplitude. So, it is double than this thing. So, that is why it is showing the 0.6 micron in both the cases, in these cases. So, that is not the correct way, but if you provide the same loading or impact in this polymer concrete, now you can see that it is not even half of this thing. So, 0.15 micron or something is there, and that is the advantage of using polymer concrete for the machine tool structure. Now, these are some of the advantages. Other than that, what you can get the long term stability, and this long term stability is very important, because when you are using at micro scale machining, at that time what you are end up, that after 6 months or after 1 year, the machine is not behaving as it should behave after some usage. So, if you are using a polymer concrete material, even though it is very costly, but the cost is actually compensated by the precision and the whatever the rigidity you are getting and thermal stability what you are getting compared to the other parts. So, that is one of the advantages why you are using costly material, but still it is compensated, cost is compensated with respect to the different parameters and the long term stability of the machine tool. Now, coming to the guideways. So, now what are the guideways? So, guideways, that means on which you are putting all the components. So, if you are using a spindle, then on the spindle you are putting this guideway, because you have to move z axis in this direction. So, this will be the z axis when you are mounting vertical, and if it is in xy table, then it will be, you need 2 in this case. So, one is moving in x direction, one is moving in y direction, and then you are guiding that movement particular in different directions. So, these are the two things. So, this is the linear guideway and these are the box type guideways. So, here everything depends on that how much you are moving in this direction. So, accuracy of micro machine components depend on the precision of the guideways. So, now if you see this thing, this is mostly you will find in the large capacity machines, and that is not the case in the micro machining. The axis of guideway should have high acceleration as well as stiff bearing to compensate the forces, because now say if you are using this thing for x and y direction, then what will happen, your z axis will come here, your tool will be here, and you have a workpiece and everything located at this location. So, when you are moving in x direction or y direction, you have to actually encounter, first is the acceleration, how quickly you are moving your workpiece in these two directions under the effect of forces. That means, when you do machining with a high depth of cut, you will end up with the more machining forces, or you are going with a high feed rate, then again you can get the more forces in the machining process. So, it should have high acceleration because you quickly want to complete the particular processing step, but it should have high stiff bearing or the overall stiffness. Let us not consider only bearing only, overall stiffness is more important, so that it can compensate the forces which are acting during the machining operation. So, in the next lecture what we will see, that we will continue this guideway, that what are the different guideways and which guideway we can use for the micro machining center, that we will cover in the next class. Thank you very much.